So the last circular function we have to learn is the tangent function. So hopefully you learned somewhere in geometry that sine was opposite over hypotenuse. So we're starting with the so. Cosine was adjacent over hypotenuse, ca. And then you learned that tangent was the opposite over adjacent. Well, where'd they get opposite over adjacent from? This is what's more powerful in trig. The definition as tangent being defined by sine divided by cosine. So if we just substitute it in, sine is really the opposite side over the hypotenuse, and that cosine is the adjacent side over the hypotenuse. Hopefully you remembered a quick cancellation leaves us with opposite over adjacent, thus getting us TOA. So in a unit circle, you now really have 3 identities there. So in other words, if I asked you what the tangent of 60 is, well, you would sit here and say, well, I don't know what the opposite and the adjacent side is. You should. But the x value we remembered was cosine, and the y value was sine. So tangent, we just learned, was opposite over adjacent, or sine over cosine. So for example here, if I wanted to do the tangent of 60 now, I simply go to 60, and tangent is sine over cosine. The 2's cancel out, and the tangent of 60 is radical 3. And just to quickly move, how about the tangent of 150? I'll go over to 150, and tangent is sine, which is 1/2, over cosine. Now watch, it's negative 3 over 2. The 2's cancel out, and I'm left with 1 over radical 3 negative, and we rationalize that very quickly to get negative radical 3 over 3. And it makes sense that tangent is negative in this because we have a cosine that's negative in there. So this brings back to what you may see some kids doing. All students take calculus, where these letters define the quadrant they've been drawn to. So in other words, in this first quadrant right here, all sine, cosine, and tangent are positive. See, there's not a negative to be found anywhere here. In the second quadrant, sine is the only positive trigonometric value. See, the cosine have negatives in front of them. And since tangent is sine over cosine, a positive divided by a negative results in the tangent being negative. So tangent's negative, cosine's negative, only sine is positive. And you can go along through each one and realize right in here, tangent is the only one that's positive. Well, kind of makes sense now. If you look here, cosine and sine are both negative. So if tangent is sine over cosine, a negative divided by negative is positive. So if that's another way for you to remember what your values are worth when it comes to their signs, no pun intended, sine, cosine, sine, positive, negative, I cracked myself up, then use it. All right, so the tangent of 3 pi over 2, well, that's right down here, and that's the tangent of 270, and it's sine over cosine. Wait a second. Yes, tangent is undefined at 270. There is no answer to it because the cosine value is 0, and you can't divide by 0. We're going to show you a picture of that on the next page. Tangent of 5 pi means I go 5 pi's. 1, 2, 3, 4, 5. So the tangent of 5 pi is really the same as the tangent of pi. And once again, that's sine, which is 0, over cosine, which is negative 1. So the tangent of pi, or 180 degrees, is 0. So we had a sine and a cosine wave. And now we're going to look at what a tangent wave looks like. So just to review quickly, if I were to draw a sine wave, here we go. It's a hill followed by a valley. Cosine wave starts high, hits in the middle its absolute low, and ends high. So remember, the sine was tracing the height of the unit circle. And the cosine was tracing the length of x, or the x-axis. So the tangent wave is tracing the division of those two. And this is what the tangent wave looks like. Get that stupid thing out of there. Wow, it's a little wackadoodle. But that's because, remember, right here at 90, we have what's called our friend, the asymptote. The tangent wave is going to get very, very close to 90 degrees, but it's not defined at 90 degrees. And that happens again, as we saw on our other page, right here at 270. So if I were to take the tangent of 90, or pi over 2, let me change that pen because that looks a little weird. Well, that's the sine of 90 over the cosine of 90. Whoops, I'm mixing metaphors here. I should stay in radians. Pi over 2, cosine over 2. And if I come back here and I put that sine cosine, oh my God, that's just looking really crazy. But if you look closely here, right there at that pi over 2, cosine was at 0, sine was at 1, and that is undefined. And that's going to happen again here at 270. So once again, here's my tangent wave. Just drawing a couple of times so you can see the points. And the tangent is undefined at 2 places. All right, so what are they going to have us do with this? It's just another wave, and we're going to study more and more of these waves. In fact, in Unit 5A, as I'm going to call it, we're going to even look at more sine and cosine waves doing wacky things. But if the sine of A is negative 5 over 13 and A is a quad angle in the fourth quadrant, can we find the cosine and the tangent of it? Well, there are 2 ways to do it. Anytime they start talking about quadrants, I like to draw the picture. Here's the fourth quadrant. There was some angle in the fourth quadrant. Here's my unit circle. And there was, well, you get the idea. There was some angle. This is always the angle. The angle is always measured. The reference angle is always measured from the terminal side of the angle to the x-axis. We draw our little right triangle, and they gave us some information. The sine is 5 over 13. So 5 goes here, 13 goes here, because sine is opposite over hypotenuse. We know the 5 carries the negative because this point is really a direction of going in the positive direction on the x-axis, going the negative direction on the y-axis. They want us to find the cosine and the tangent. Well, this is pretty easy to do. I can just do Pythagorean's theorem to find this side over here. Hopefully we know by now that that's 12, and this became a very easy problem to do. Well, then the cosine of this angle is 12 over 13, and the tangent of this angle is opposite over adjacent. Well, that's one way to do it. The other way to do it, remember, was our Pythagorean identity. We saw that sine squared theta plus cosine squared theta equals 1. Well, and for sine, we would have put 5 over 13 and just proceeded to do our math. And cosine squared theta equals, make that into 169 over 169, and we get 144 over 169. So that means the cosine of theta is 12 over 13. Remember, it could be a plus or a minus, but since we're in the fourth quadrant, and we can go back to this, all students take calculus. In this fourth quadrant, only cosine is positive. Notice sine was negative over here. So we could say that the cosine is 12 over 13, just like we got right here. And then to get the tangent, well, there's no tangent in this Pythagorean's identity. We could have just recalled that tangent is sine over cosine. Cancel out the 13s, and it's negative 5 over 12. So I don't care which way you do it. Just learn one way. Okay, let me clean that up so we can, I'll just drag down. And let's look at the last. If the point negative 0.6, 0.8 lies on the unit circle, okay, that's different than up here where we didn't say it laid, lied, lone, whatever the past tense of to lay is. We said it's just an angle in the fourth quadrant. We had to find the unit circle. This unit circle over here had a unit of 13. This, they already tell us it's a lovely unit circle. Great, find the cosine, sine, and tangent. This, people, is easy. The sine of my angle is, since it's already defined as being on the unit circle, 0.8, because that is the value of the y. The cosine of theta, we love this problem, is negative 0.6, because that's the cosine, the x. And then the tangent is simply sine over cosine. Woo-woo! So that is going to be negative 8 over 6, after I move the decimal to make this easy, negative 4/3. Now guess what? You're going, whoa, whoa, whoa. Tangent can be greater than 1? Yes, it can. We're going to look at that tomorrow a little closer in class. So here's your summary. We know a point on a unit circle is defined by cosine sine. Tangent is simply sine over cosine. And a tangent wave, which we will look at more, let me get a better drawing here, looks like this. 90, 180, 270, 360. All right, so remember we saw that right here, this was pi over 2, pi, 3 pi over 2. Yay, you can hear my dog in the background finishing her breakfast. And a tangent wave looks like this. It approaches 90, it gets very, very high, but it never touches pi over 2. It's undefined there. It's an asymptote. Likewise, at 3 pi over 2, it's another asymptote. So basically, at every 180 degrees, from 90 to 270, now go another 180 degrees, we're going to have our asymptote where tangent wave is undefined.